Hey guys, Team 10 here, and our group challenge project is nuclear fusion. More importantly, making power from nuclear fusion. Section 1. What is fusion? Basically, nuclear fusion is when two atoms hit each other so hard that their nuclei combine and it releases a bunch of energy. Fun fact, this is actually the process that powers the sun. Section 2. Why is fusion important? Now I know what you're thinking. Power from fusion. Why do we need that? Aren't our current nuclear reactors good enough? Bam! Wrong-o. Current nuclear reactors use a process called fission, where an atom is split to release energy rather than fused, and it sucks compared to fusion. Current nuclear reactors require mining of dangerous radioactive isotopes, result in tons of nuclear waste, and if they melt down, then you get Chernobyl. Fusion, on the other hand, uses hydrogen and helium, has harmless byproducts, and doesn't create an 1,000 square mile nuclear wasteland when they fail. Section 3. Why is fusion hard? So if this nuclear fusion is so good, why don't we use it instead of fission? Because it's hard, duh. Fusion requires both extreme heat and pressure. The sun is able to get fusion to happen at a relatively low temperature, only 27 million degrees Fahrenheit, because it has so much pressure at its core from its own mass and gravity. But if we want fusion to happen on crappy low pressure Earth, it needs to be nearly 6 times that temperature. And even when we do get it that hot, it ends up taking more energy to produce the reaction than is actually released by the fusion. Section 4. Potential solutions. So there are currently two main ways to get fusion to occur on Earth: magnetic confinement and inertial confinement. Magnetic confinement works by heating up a stream of hydrogen gas with microwaves and electricity until it turns into plasma. Then squeezing that plasma with super strong magnetic fields produced by liquid helium-cooled superconductors. The other method, inertial confinement, is done by basically shooting a bunch of lasers at a small piece of fuel, heating it into plasma, and putting enough pressure for it to fuse. Magnetic confinement is the more researched of the two and seems to be the most promising, with the ITER, a test fusion power plant, set to be finished in 2025. Section 5. Conclusion. In conclusion, nuclear fusion is basically the perfect power source, with readily available fuel, extreme efficiency, no dangerous byproducts, and no meltdowns. But it still hasn't been put into practice yet because you basically have to make a sun in a tube, which isn't very easy. Scientists are actively pursuing promising looking methods, and we believe this is a problem worth solving.